Now we're going to talk about exposure. Exposure, when you're talking about video or pictures, is how bright the image is, whether or not the appropriate amount of light was allowed into the camera to make it look the way it's supposed to look. So if the image looks proper in terms of brightness, if you've got detail in your highlights and detail in your shadows, it's properly exposed. If you let too much light into the camera, that's called overexposure. If an image is overexposed, you lose detail in the highlights. All of your whites turn into big white blurs. There's no detail there. They're just slabs of white. What should be fluffy white clouds in the sky are just big white blobs in a big white sky. The other end, if there's not enough light, if the image is too dark, that's called being underexposed. The same thing happens except to the shadows. You lose all the detail at the low end of the picture. All of the shadows just turn into black. There's no detail. Your shadowy figure that was hiding in the bushes is simply black in an area of black. There's nothing there. So we're going to learn how to control this. And there are actually 4 ways that you can control your exposure. The first method for controlling your exposure that we're going to talk about is to work with the aperture of the camera. Now here I have an old Nikon film camera, and we're going to use this as a demonstration. Inside the lens, there's a little hole that goes all the way through, and I can change the size of that hole. You can see it getting smaller here, and getting larger. That hole that you're seeing is called the aperture. And light travels through the aperture to reach the inside of the camera. The metal blades around the aperture are called the iris. This is like the iris of your eye, right? The colored part of your eye is called the iris, and it expands or contracts to let the pupil expand or contract so that more or less light comes through. So this has exactly the same function. The lens has exactly that same function. As the hole gets larger, more light comes through, and as the hole gets smaller, less light comes through. The size of the aperture is measured by a series of numbers called f-stops. And if you look at the edge of the camera here, you can see these numbers changing as I turn the iris ring. This is making that hole larger and smaller. You're going to need to know the series of numbers that are f-stops. In a common lens, a lens that you're likely to see, wide open is at f1.4, and then as you close down one stop at a time, you go to f2, 2.8, 4, 5.6, 8, 11, 16. On more expensive lenses, you might be able to close down even further. You might be able to go to f22, 32, 42. You might be able to open beyond f1.4. You might be able to open to f1, f.7, f.5. But these are phenomenally expensive pieces of glass that you're not going to see in my class. The cameras that we do have, the cameras that you're likely to be working with, at least in the near future, all fall between f1.4 and f16 in the terms of available f-stops. You need to know these numbers. You need to memorize these numbers. You need to be able to do these numbers backwards and forwards. This is going to be with you all semester long, so go ahead and take the time, start looking at these. On this lens, the only numbers that you see are the whole f-stops, right? f16, f8, f4. You won't see any fractions, and the lens won't let you select halfway in between. On modern cameras, like the JVC that I'm shooting on, like the one you'll be using for this class, you can have half stops or even 1/3 stops. So there will be numbers in between. So in between f4 and f5.6, you'll have f4.5, f5. You don't need to memorize all of these, right? You don't need to memorize the half stops and the third stops, but you can look at a number, and if it says f7.1, you know that you're in between f5.6 and f8. Now, just to complicate things, on higher end lenses, there's actually a different system of measurement called t-stops. If you're around next year, we're going to have some cinematic lenses and we'll actually get to play with that. But for now, forget about it. You can remember that t-stops exist, and there is a second system of measuring the diameter of the aperture. But for now, f-stops. That's all we're going to focus on for this semester is f-stops. Every time you open one stop or close one stop, you're changing the amount of light that's coming through by a factor of 2. If you open one stop, you make the iris one stop larger, twice as much light will come through. If you close down one stop, half as much light will come through. So everything in exposures is about multiplying or dividing by 2, except when it's not. But usually everything in the calculating exposure is about multiplying or dividing by 2. Keeping that in mind, what happens if we start at f8 and we open the lens 3 stops to f2.8? So from 8 to 5.6, 5.6 to 4, 4 to 2.8. How much brighter is the image? The answer is that it's 8 times as bright, right? Because when we opened up from 8 to 5.6, we doubled the amount of light coming through. So that was times 2. When we went from 5.6 to 4, we doubled the amount of light coming through again. That's 2 times 2 is 4. When we opened from f4 to f2.8, we doubled the amount of light again. So that's 2 times 2 times 2 is 8. So by opening 3 stops, we have let 8 times as much light come through the lens. If you start at f4 and close down 2 stops, where do you end up? The answer is f8. This is phrased a little differently. Your iris is set to f5.6, but the image is dark. It looks like it's 2 stops too dark. How are you going to fix this? You're going to open the iris by 2 stops, which will take you to f2.8. Understanding what happens when you open and close the iris is very important. Make sure you've got a good grasp on this, because the iris is only one of 4 variables that you're going to be manipulating by the time we get to the end of this. So take a minute, look over those f-stops again, commit those to memory, and make sure that you know which way is opening, which way is closing. It's easy in your head to sometimes get them turned around. The larger the number, the larger the f number, the smaller the hole and the less light. So f16 is a very small hole and it lets through very little light. f1.4 is a very large hole. It lets through a lot of light. It seems counterintuitive that they should run a smaller number means more light and a larger number means less light. So drill with these, practice these, make sure you know these because you need them. All right, next we're going to talk about shutter speed.